Hey kids, how are you doing? I am recording this other video so you can get some information for practicing previous or partial tests. Well, like the goal for today was practicing with the combined and the general formula for gases. So you're going to see how some exercise looks like by paying attention to this one. I already underlined the most important information, but let's read it again. It's what volume is occupied by 15.03 grams of oxygen gas at 28 Celsius degrees and at a pressure of 0.988 atmospheres. Well, I underlined the most important variables in this exercise. You can see there's just one volume. They are asking for calculate. And for a mass of gas at that specific temperature and at that specific pressure, it doesn't say from initial and final state. It's just in just one single state, what will be the volume if you have those other variables? Of course, for oxygen gas and the mass of gas. So after underlying the most important information, I would like you to take into account the data first, like as we read. For example, A, I am just using A for symbolizing the mass of, or the given mass of oxygen, like the sample of gas, which is being measured 15.03 grams of oxygen gas, the mass of the gas. So that's basically A. That's why it says AO2, as you can see here, AO2, mass of oxygen gas. Well, also I forgot to write out something very important, which is at first it said, what's the volume? So that's why I put the volume and the question mark for saying that we're looking for the volume. After that, something which is very important for you to write that is the temperature, and you pass it to 900, you pass it to Kelvin. Well, I will correct it. It's not 298 Kelvin in this moment. It's going to be 301. I will correct it later on forward in the video. The pressure is 0.988 atmospheres. And then something which is very important for you to remember is, okay, what else can I do there? Let's just have those data. We're not talking about initial and final states. We're just talking about what would happen in this moment, like at this temperature, at this pressure, and what volume this gas is going to occupy. Simple as that. So whenever you're talking about something very important, whenever you're reading some gases, if they're giving you so massive a gas, then you might be talking about the general formula for gases, with the one that uses number of moles. So definitely, if you have the mass, you are going to be, maybe you're thinking already about passing the grams of the oxygen to moles. That's going to be really wise. That's exactly what I'm going to do in this moment. So you open the conversion factor as we studied before, and you just basically put it like this. So I just put the equivalence, knowing that the mole of any gas occupies specifically 32 grams of oxygen, right? So you put the equals there and then have passed the 1503 grams of oxygen to the moles of oxygen. And now basically, so that becomes another important data, like I just put it in here. For example, if you pay attention to this specific part, it says like, yes, of course. So the MO2, that's the molecular or the molar mass, to be precise, sorry, the molar mass, which you obtain from the periodic table. You know that one atom of oxygen has a molar mass of 16. Since oxygen is a gas, then the molar mass of the gas is going to be the mass times 2, which is 32 grams of a mole. To be precise with that, that's another important data. And also we just calculated the number of moles. So, okay, I have all of those variables. How can I relate all of those variables in one single equation from the ones we have studied? So maybe you're thinking, well, yes, of course, it's the general formula for gases, right? So yes, because we're looking for the volume, we do have the pressure, we do have the number of moles, we do have the general constant for gases and also temperature. So if you get forward, you enclose the variable you're looking for, which in this case is the volume, right? The question mark we put there. So then you solve the equation for that. In Spanish, you say despejar that variable. So it would be like that. So you solve the equation for volume, and after that, you get started to replace, right, the values there. So in the first place, I want to get started, like put in there. So the 0.47 moles of oxygen, which is the number of moles, and the general constant for gases, as we calculated before, the 0.082 liters times atmosphere or mole times Kelvin. That's the general constant for gases, so it never changes. And also the temperature, I told you I was going to correct in the forward video. After adding the 28 Celsius degrees plus 273 is 301 Kelvin. We put that there. And all of that divided to the pressure, right? And once you have replaced, that's why it's more important for you to put the units, and that's the way you should solve the exercises regarding any sort of chemistry. So you see the units, and after that, we make sure that you get to cancel, right, the units, and you remain with the units you're looking for. So in this case, it's volume, but you should stay with volume at the end. Like, so you cancel atmospheres with atmospheres, moles with moles, Kelvin with Kelvin, and at the end, you remain specifically with the liters. So you perform the calculation, so the value, those values there, and you're going to have that something like that, 11.62 liters of oxygen. Something very important also that we could get by seeing this conversion specifically in here from this, which I love you to this from stoichiometry, like you did this conversion from grams to moles. We can easily say, if you want to put it also in an equation, just for you to remember, that the number of moles of anything, right, is basically like the mass or the given mass, if you want to write like the given mass divided to the molar mass, right? It's something like that. So you put that there. Yes, the given mass divided to the molar mass of that compound. That's what we did. If you check the conversion factor which is used, we did that. The given mass was the 15.03 divided to the molar mass of the gas in this case, or any kind of substance, is 32 grams of that. And then we got the number of moles. Being said, so that was it, my dear students. That's the way I want to help you practice with this, and see you.